Before the ocean existed, Earth was a violent world of fire, rock, impacts, and molten landscapes. The surface was too hot for stable oceans, while volcanoes continuously released gases into the young atmosphere. But slowly, Earth began losing heat, and something extraordinary started happening above its volcanic surface. For perhaps millions of years, rain fell onto the cooling planet, collecting in its lowest basins. Those waters accumulated, merged, and eventually formed the first enormous ocean basins. This first ocean looked nothing like today's blue seas. It was chemically different, warmer, and surrounded by volcanic continents. And somewhere beneath that ancient water, chemistry began producing something far more important than rocks. Tiny microscopic organisms appeared, beginning a biological story that would eventually transform the entire planet. For billions of years, life remained microscopic, multiplying through oceans that stretched across an almost alien Earth. Some microbes built layered structures called stromatolites, leaving behind some of Earth's oldest biological signatures. Then photosynthetic microbes began releasing oxygen, slowly changing the chemistry of the ocean and atmosphere. Much later, Earth entered extreme ice ages, and enormous portions of the ocean may have frozen over. Yet life survived in protected environments beneath the ice, waiting for the planet to change again. Eventually, the ice retreated, oceans warmed, and life entered one of its greatest transformations. By roughly 600 million years ago, increasingly complex organisms were beginning to reshape the ancient seas. Then came the Cambrian explosion, when the ocean suddenly became crowded with new forms of animal life. For the first time, powerful predators hunted prey through ecosystems that increasingly resembled modern food webs. Among these ecosystems appeared early chordates, distant relatives of the animals that would eventually dominate the seas. Eventually, vertebrates evolved into fish, giving the ocean a new kind of predator and survivor. Then jaws appeared, giving some fish the ability to bite, hunt, and compete in entirely new ways. Some predators became enormous, turning ancient oceans into dangerous worlds ruled by giant fish. And while the ocean evolved, some of its inhabitants began making the first steps toward land. Then Earth experienced its greatest mass extinction, and the ocean's ecosystems collapsed on an enormous scale. Massive volcanic activity altered climate and ocean chemistry, pushing countless marine species beyond survival. But extinction created empty ecological spaces, and surviving life slowly began filling them again. During the Mesozoic, reptiles returned to the sea and became some of its most spectacular predators. During Jurassic era, marine reptiles hunted beneath the waves, while enormous schools of fish filled the ancient continental seas. At times, shallow seas spread across continents, creating enormous marine habitats where today's cities would one day stand. Reefs expanded, supporting enormous communities of fish, mollusks, crustaceans, and microscopic life. Then 66 million years ago, a mountain-sized asteroid crossed Earth's path and changed the ocean forever. Its impact triggered enormous waves, atmospheric disruption, darkness, and a global ecological catastrophe. Once again, the ocean lost dominant species, but again, according to nature's rule, survivors remained. After the dinosaurs disappeared, another group began an extraordinary journey back into the ocean: mammals. Their descendants gradually became fully aquatic, eventually producing the largest animals Earth has ever known. Today, the blue whale can reach lengths greater than 30 meters, feeding on tiny organisms beneath the waves. From microscopic plankton to giant whales, nearly every level of this enormous food web is connected. And the ocean is not merely scenery. Microscopic marine organisms produce a huge share of the oxygen entering our atmosphere. Its currents also move heat around the planet, helping regulate Earth's climate. But beneath the sunlit surface lies a world of darkness far larger than most people imagine. Hundreds of meters below the surface, sunlight fades into a twilight world filled with strange adaptations. Far deeper, sunlight disappears completely, yet life continues around the ocean floor. Around hydrothermal vents, entire ecosystems survive using chemical energy instead of sunlight. For most of human history, the deep ocean remained almost completely beyond our reach. It was considered an alien world. Then ships, maps, submarines, and technology slowly pushed humanity farther into the unknown. In the 20th century, humans finally descended into places where sunlight had never reached. Today, humanity depends on the ocean for food, climate regulation, transportation, and countless unseen biological services. But our relationship with the ocean has also created a new geological problem: enormous amounts of plastic waste. As the planet warms, the ocean absorbs enormous amounts of heat, changing marine environments around the world. Coral reefs, among the richest ecosystems on Earth, are especially vulnerable to changing temperatures and chemistry. As the ocean absorbs carbon dioxide, seawater chemistry changes, making it harder for some organisms to build shells and skeletons. Yet the ocean has survived planetary catastrophes before, and life continues to adapt in remarkable ways. In the future, changing climate and sea levels could redraw coastlines that humans currently consider permanent. Thousands of years from now, today's coastlines, ports, and cities may be almost unrecognizable. Over millions of years, plate tectonics will move continents, creating and destroying entire ocean basins. Eventually, Earth's continents may gather into another supercontinent, reshaping the ocean around them. The ocean would still exist, but its shape, chemistry, currents, and inhabitants could be completely different.